Okay, so this lesson is on properties of exponents. Now there are three properties that we're going to talk about in this lesson. The first one is called the product rule. Now let's kind of review something about the product rule from a previous course. So remember the product rule for exponents from a previous course. When you multiply like bases, you add exponents. So remember it was b to the m times b to the n is b to the m plus n. All right, so that was a previous course. So it's called the product rule. Now there's also a product rule for logarithms. So let's talk about this product rule. Now remember, a logarithm is an exponent. So this idea about when you multiply like bases, you add exponents transpires, or you can think about it in terms of a logarithm as well. So if you have the log of a product, let's say m times n, regardless of the base, remember the base must be positive, it cannot be equal to 1. But the log of a product, if you think about the product rule, you add the exponents. So the log of a product can be written as the sum of the two logs of each factor. So you have the log of m base b plus the log of n base b. All right, so when you have the log of a product, you write it as a sum of two logs. Okay, the sum of two logs. So it's a log of m plus the log of n. And just think about the product rule for exponents. When you multiply like bases, you add exponents. Okay, now in the next lesson, we're going to be given this, and you have to rewrite it back as a product. Okay, so notice the base though. Whatever the base is here, you got to put it here. You can't leave it blank. It must be listed again. So the log of the product m times n base b is equal to the log of m base b, so the first factor, plus the log of the second factor n base b. Okay, so that's a product rule. So for example, if you have the log of, let's say, 15x, let's do log, sorry. Let's do log of 15x base 6. So according to the product rules, I'm taking the log of a product. So you got to notice that this argument, let's call this the argument. So the argument here is a product. So the log of a product can be written as the sum. So it'll be the log of 15 base 6, so the first factor, plus the log of x base 6. So that's how you write it. So notice how it looks though. The 6 is a subscript. Make sure the 6 looks like a subscript. Okay, so that's a product rule. Now, there's something else you got to remember. So I'm going to call this number 1, and I'm going to call this number 2. If you have the log, let's say the log of, let's say 100y. Okay, so the log of 100y, now remember there's no base there, it's understood to be 10. So if there's no base, it's understood to be 10. So remember that's called your common logarithm. So if there's no base, it's understood to be 10. So remember when we wrote this though, we wrote this as, using a product rule, you can write this as the log of 100 plus the log of y. Now remember, again, there's no base, but it's understood to be base 10. Which, if you remember though from a previous lesson, is that you can simplify the log of 100. So remember the log of 100, so you must simplify if you can without using a calculator. If you can simplify this without using a calculator, then you need to do it. So log of 100, remember you ask yourself, 10 to what power is 100? So 10 squared is 100. All right, and so this becomes a 2 here. So that's 2 plus the log of y. All right, so that's the product rule for logarithms. Now let's talk about the quotient rule for logarithms. So the quotient rule. The quotient rule. So remember in a previous course, the quotient rule for exponents look like this. If you have a base raised to the m power divided by the same base raised to the n power. So remember when you divide like bases, you subtract exponents. So this becomes b to the m minus n. So that's the quotient rule. So in terms of logarithms, it's the same idea. So you have the log of some base, and you're taking the log of a quotient let's say m, that's an m, divided by n. All right, so you're taking the log of a quotient, base b. So according to the product rule, when you divide like bases, you subtract exponents. I'm sorry, quotient rule. When you divide like bases, you subtract exponents. Remember, the log is an exponent. So the same idea applies here. So the log of a quotient you write as a difference. So it'll be the log of the numerator, base b, minus the log of the denominator, base b. So that's how it looks. So the log of the numerator, base b, subtract the log of the denominator, base b, so the log of n. Okay. And so in terms of a problem, let's look at this. So suppose you have, all right, so example, now the directions will say use the properties of logarithms. Use the properties of logarithms to expand as much as possible. Okay, so let's look at number 1 for this one. So number 1, suppose we had the log of 5, the log of this quotient. Let's say the quotient was 18 divided by y. Alright, so according to the quotient rule, I can rewrite this as a subtraction problem. I can rewrite this as a difference of 2 logs. So it would be the log of the numerator. Don't forget the base though. If you leave the base, if you don't put the base, you're saying the base is 10, and the base is not 10, the base is 5, so you must put the base. Subtract the log of the denominator, base 5. Okay, so that's that. Number 2, suppose you had the natural log. Suppose it was the natural log of let's say e divided by 6. So natural log of e divided by 6. So according to the quotient rule, that's the natural log of e, subtract the natural log of 6. Now remember, in a previous lesson, we talked about the natural log of e, figuring out what the natural log of e was without using a calculator. So remember, the natural log of e means the log of e base e. So remember, ln is a log base e. So we can figure out what that is. We can figure out what this is equal to without using a calculator. So e to what power is the argument, e. So e to the first equals e to the first. So that's a 1 here. So this becomes a 1. So that's 1 minus the natural log of 6. Okay, what about this one? Suppose you had the natural log of e to the 7th power divided by 4. Let's suppose you had that. Well, again, using a quotient rule, that would equal the natural log of e to the 7th minus the natural log of 4. All right, now in terms of what you can simplify this without using a calculator. Now you need a calculator for this one, which you're going to leave it as natural log of 4, so you're not going to put an approximation here. But here you can figure it out from the previous lesson. Remember what that is. Let's figure out what this is from the previous lesson. From the previous lesson, without using a calculator, you're trying to figure out what this equals. Well, remember, the natural log is really log base e of this argument. So ln is log base e. All right, so let's figure out what this is. So we can change this log equation to an exponential. So you say e to the box, so e to some exponent equals the argument, which is e to the 7th. So remember, when the bases are the same, the exponents have to be the same. So this has to equal a 7. So this must equal 7. So that's a 7 here. So this is a 7. So I get 7 minus the natural log of 4. Okay? All right, now let's look at the power rule. So let's talk about the power rule. All right, the power rule. Okay, so the power rule, remember from a previous course, looked like this. So if you have b to the m power, and that's raised to the n power. So remember, basically, this outer n, this outer exponent n, says that you're going to multiply b to the m by itself in factors, n times. Okay, so you also learned that when you have a power raised to a power, an exponent raised to an exponent, you multiply these exponents. So this is really b to the m times n. Okay, so the power rule, you're going to multiply those exponents. That's what that implied from a previous course. Now, using that idea with logarithms, this is what you have. You're going to have the log base b of m to some power p. All right, so remember, the log itself is an exponent, and then you also have this exponent here. All right, so according to the power rule, I just multiply the exponents. So this itself is an exponent. This is an exponent. So basically that means I can write this as the exponent p times the log of m base b. So that's what that means. So basically, if you look at it like this, let me go ahead and rewrite it. You're going to take this outer exponent and you're going to rewrite it as a product. So you're going to say, I'm going to take this exponent p, I'm going to say p times the log of m base b. That's how you write that. So for example, okay, so let's suppose you had the log of 6 times 3 to the x power, let's say. Log base 6 of 3 to the x. Log base 6 of 3 to the x. So basically, you can use a power rule. So you can take this exponent x, you're going to write it in front, and so that's going to be x times the log of 3 base 6. So x times the log of 3 base 6. Okay, number 2, suppose you had, let's say you had the natural log of x to the 4th power. So again, remember the logarithm is an exponent, so you have this also exponent here, so you're going to, according to the the power rule, you multiply exponents. So you can rewrite this as 4 times the natural log of x. And that's all you can do there. Okay? Alright, so we talked about the product rule for exponents, for logarithms. So the log of a product, you're going to write as an addition problem. So it's a log of each individual factor. So the log of m base b plus the log of n base b. We talked about the quotient rule for logarithms. So the quotient rule says the log of a quotient m divided by n, you can write as a subtraction problem, as a difference. So it'll be the log of the numerator, base b, minus the log of the denominator, base b. And then the power rule, so when you have a power is a power, so in terms of the power rule for logarithms, you're going to take this exponent and you're going to write it as a product. So it'll be p times the log of m base b. All right, so those are the 3 properties that you're going to use, and those are important properties. So let's look at some examples with these. So we're going to look at some simple examples first, and then in the next lesson we'll look at some more complicated but not that difficult examples. All right, so the directions will say use the properties of logarithms. Use the properties of logarithms to expand each logarithmic expression as much as possible. Okay, and then whenever possible, simplify without using a calculator. All right, so let's look at, let me get this out here. So let's look at this example. So I'm trying to find some examples similar to the ones on your worksheet. So let's see, this is section 4.3. So 4.3 part 1 on your worksheet, it looks like this. Okay, so let's do these. Number 1. All right, suppose we had the log of 7x base 7. Log of 7x base 7. All right, so I'm going to use a product rule here because I'm taking the log of a product. So that's my argument. My argument is a product. So according to the product rule for logarithms, that becomes the log of 7 base 7, that's a 7, plus the log of x base 7. Now remember, the directions will say simplify as much as possible. So we expanded it. So we used the product rule. But I can simplify this one here, because remember from a previous lesson, the log of 7 base 7, so you got to recognize when you can simplify without using a calculator. So from a previous lesson, so you can use the stuff from the previous lesson. So 7 to what power is 7? So this is a 1 here. So this is a 1, so this becomes a 1. So that's 1 plus a log of x base 7. So that's your answer. So that's what it looks like. Number 2. Suppose you had the log of, let's say, 1,000 y. So let's suppose that was the problem. Now remember, there's no base. It's done to be 10. So this becomes, remember, taking the log of a product. So I'm going to use a product rule for logarithms. So that's a log of 1,000 plus the log of y. Now I can simplify the log of 1,000 because remember that means log of 1,000. So you want to figure out what that exponent equals. This basis is 10 here, so you'd say 10 to some power equals 1,000. Well, 10 to the third equals 1,000. So that's a 3 here. So that's 3 plus the log of y. Number 3, suppose you had the log of, let's say, 6x base 2. Log of 6x base 2. So according to the product rule again, so I'm taking the log of a product, the arguments of product. So I get the log of 6 base 2 plus a log of x base 2. And I can't simplify this, so you need a calculator for this, but you don't know how to do yet. Okay, number 4, suppose you had the natural log of, let's say, 5e. Natural log of 5e. So according to the product rule, that's going to be the natural log of 5 plus the natural log of e. So the natural log of 5, I would need a calculator, so I'm going to leave it like it is. But the natural log of e, I can simplify without using a calculator. So you got to remember the natural log of e. So natural log is log base e, and then you're taking the log of e base e. That's what this means, log of e base e. So if you change this log equation to an exponential, that becomes e to a power equals e. So the base is the same, the exponents have to be the same. So since that's a 1 here, this is a 1. So that's a 1 right here. So this becomes a natural log of 5 plus 1. Or you can say 1 plus the natural log of 5. Does not matter. Okay, number 5. Alright, suppose you had, alright, let's do some quotients. Suppose you had the natural log of y divided by e. The natural log of y divided by e. Well, according to the quotient rule, that's going to be the natural log of y minus the natural log of e. So remember, the quotient rule you're going to write as a subtraction. So it's the natural log of the numerator minus the natural log of the denominator. This part here we just talked about. I can simplify that. So I know already that that's equal to a 1. So that's natural log of y minus 1. Now if you want to rewrite it, you have to be careful though. That's really negative 1 plus the natural log of y. That's what that is. So this is the same thing as this. But just go ahead and leave it like this because that's how you wrote it. Natural log of y minus 1. So that's your answer. Number 6. Suppose you had, let's say, the log of 7 divided by y, base 7. Let's make that base 7. Log of 7 divided by y, base 7. So again, that's a quotient, so you use a quotient rule. So when you think about quotient rule, you think subtraction. So that's a log of 7 base 7 minus a log of y base 7. So make sure you put your bases. I can simplify this from the previous lesson. So the log of 7 base 7, I know what that equals. 7 to what power is 7? Well, the base is the same. The exponents have to be the same. So that means that this must equal 1. So that's a 1 here. So I get 1 minus the log of y, that's a y, base 7. So that's your answer. Okay, number 7. Suppose you had, let's see, suppose you had the log of x to the 5th power. Alright, so notice that this is a power rule here because you see this exponent. So according to the power rule, whenever I'm taking the log of something raised to a power, I take this exponent and I rewrite it as a product. So that's going to be 5 times the log of x. That's all you do. There's your answer. Number 8, suppose, let's see, number 8, let me go to the next one. Alright, so number 8, suppose we had this. Suppose we had the natural log of e to the 6th power. Natural log of e to the 6th power. So I can use the power rule. So it's going to be 6 times the natural log of e. And then the natural log of e, we know is, remember the natural log of e is log of e base e. So you're trying to figure out what that exponent equals. So it's e to some power equals e. Whenever the base are the same, the exponents have to be equal. That's a 1. So that's 6 times 1, which is 6. So same thing here if you had something like this. If you had the log base 6 of 6 to the x power, let's say. So I'm going to go ahead and rewrite this. So the log of 6 to the x base 6. Log base 6 of 6 to the x. So I take that power, so I'm using the power rule. Pull that in front, write as a product. So that's x times the log of 6 base 6. You got to remember from the previous lesson that the log of 6 base 6, when you write as an exponent, that's going to be 6 to some power equals 6. So when the base is the same, the exponents have to be the same. So this has to be 1. So this right here is a 1. So you get x times 1, which is just x. So the answer is x. Okay, so that's going to take care of this part.